June 26, 1944, Hollandia Air Base, Dutch New Guinea. The checkerboard sat abandoned on the crude wooden table as Lieutenant Colonel Charles MacDonald lifted his eyes toward the screen door. A man stood there, framed by tropical glare and dust, repeating his name with quiet assurance. MacDonald had barely registered the introduction at first. His attention had been on the game, on Lieutenant Colonel Merrill Smith across from him, operations officer for the 475th Fighter Group, Satan's Angels. But the name, spoken again, cut through the moment. Charles Lindbergh. Not a nickname, not a coincidence. Charles Lindbergh, the aviator who crossed the Atlantic alone, the most recognizable pilot on Earth, was standing thousands of miles from America, asking permission to talk about P-38 combat operations. Neither man could have known that this interruption would reshape the way long-range air combat was fought in the Pacific. Over the next 6 weeks, the techniques Lindbergh introduced would stretch the combat radius of the Lockheed P-38 Lightning by nearly 400 miles. What pilots believed to be absolute limits would become routine mission profiles. What had been considered impossible would quietly become doctrine. This was not simply a story of engineering, it was a story of resistance, proof, and transformation, of pilots learning to trust numbers over instinct, of deeply ingrained training giving way to measurable results, and of one civilian's mastery of fuel efficiency altering the operational tempo of an entire theater of war. The mathematics of extended range were not written in manuals or memos. They were written in fuel gauges, in landing times, in pilots returning home with reserves no one believed possible. And the man teaching those lessons was 42 years old, a civilian consultant who had first flown a P-38 just 3 days earlier. The road to that screen door began 17 years earlier over the Atlantic. On May 20th and 21st, 1927, Charles Augustus Lindbergh flew non-stop from New York to Paris, covering more than 3,600 miles alone in 33.5 hours. His aircraft, the Spirit of St. Louis, carried so much fuel that forward visibility was completely blocked. Lindbergh navigated by periscope and dead reckoning, managing consumption with obsessive precision. When he landed at Le Bourget Field, 85 gallons of fuel remained in the tanks. Fuel economy that experts insisted was unattainable for a Wright Whirlwind radial engine. That attention to efficiency became Lindbergh's defining expertise. Throughout the 1930s, while conducting survey flights for Pan American Airways across the Pacific and Atlantic, he refined techniques that consistently exceeded manufacturers' specifications. He understood something most pilots did not. Published range figures were averages, not limits. Every engine possessed an optimal operating window where fuel burn, power output, and mechanical stress aligned perfectly. Finding that balance required understanding the relationship between manifold pressure, propeller RPM, mixture control, and airspeed in ways standard flight training barely touched. By 1944, Lindbergh was one of the world's foremost authorities on long-range flight. Yet his relationship with the U.S. military was fractured. His outspoken pre-war isolationism and leadership of the America First Committee had placed him at odds with President Franklin Roosevelt. In April 1941, after Roosevelt publicly likened him to Civil War-era secessionists, Lindbergh resigned his commission in the Army Air Corps Reserve. After Pearl Harbor, he attempted to return to service. Roosevelt personally ensured he would never wear an American uniform again during the war. But expertise does not disappear because it is inconvenient. Unable to serve as an officer, Lindbergh became a civilian technical consultant. In 1943, he joined United Aircraft Corporation, working extensively with the Chance Vought division on the F-4U Corsair. He assisted Ford's Willow Run plant with B-24 production issues. He conducted dangerous high-altitude test flights in P-47 Thunderbolts. He helped refine dive bombing techniques. Yet none of it satisfied him. Lindbergh wanted combat. By early 1944, he saw an opening. United Aircraft was studying future twin-engine fighter concepts, and the Lockheed P-38 Lightning was America's only operational aircraft in that category. Lindbergh persuaded the company to send him to the Pacific as a technical representative to observe P-38 combat operations. Officially, he would observe. Unofficially, he intended to prove something. On April 3, 1944, Lindbergh prepared to deploy. He bought a naval officer's uniform without insignia. He purchased a small New Testament, writing in his journal that it would not have been his choice a decade ago, but now surpassed all others. On April 24, he departed San Diego, authorized by the Naval Department but unknown to the White House. Neither Roosevelt nor the Secretary of the Navy was informed. Lindbergh was going to war anyway. What began as a discreet observation assignment changed character almost immediately once Lindbergh reached the South Pacific. Marine aviation officers, impressed by his technical grasp and reputation, invited him to fly along as an observer on combat missions. On May 21, 1944, Lindbergh flew his first operational sortie, a strafing mission with Marine Fighting Squadron 222 against Japanese positions near Rabaul. Officially, he was there to observe. In practice, he flew with his guns armed and fired when opportunity presented itself. He demonstrated calm, precision, and an understanding of aircraft performance that exceeded expectations. Working with Corsair pilots, Lindbergh identified problems others had accepted as unavoidable. The Marines were losing aircraft during takeoff because strike missions required bomb loads that exceeded the F-4U's published limits. Lindbergh analyzed power settings, airspeed requirements, and weight distribution, then demonstrated that aircraft could safely depart with loads nearly double what manuals allowed. Accident rates dropped, strike effectiveness increased. Word spread quickly through the Pacific that the famous aviator, now flying combat missions as a civilian, was solving operational problems military pilots had struggled with for months. By mid-June, Lindbergh's interest shifted toward the Lockheed P-38 Lightning. United Aircraft wanted data on twin-engine fighter performance, but Lindbergh had heard of a particular unit flying the Lightning with exceptional aggression. The 475th Fighter Group, known as Satan's Angels, had earned a reputation as one of the most lethal P-38 units in the theater. If he wanted to understand the aircraft in combat, this was the place. On June 15, 1944, Lindbergh traveled to Finschhafen, New Guinea, and reported to 5th Air Force Headquarters at Nadzab. He lunched with Marion Cooper and later dined with General Ennis Whitehead, discussing operations in New Guinea and his interest in observing Lightning missions. The authorization that followed was informal and technically insufficient, but the Southwest Pacific was not a theater governed strictly by paperwork. Competence and trust carried more weight than signatures. On June 20th, Lindbergh spent just over an hour receiving a checkout flight in a P-38 with the 35th Squadron of the 8th Fighter Group. It was his first time flying the distinctive twin-boom aircraft. 6 days later, on June 26th, he arrived at Hollandia and walked into Charles McDonald's recreation hut, interrupting a checkers game that would soon become legend. Charles was only 29 years old, but already a 10-victory ace. He commanded the 475th Fighter Group, activated in Australia in May 1943, and now among the highest-scoring P-38 units in the Pacific. The group's 3 squadrons flew the latest P-38J models with improved intercoolers and additional fuel capacity. These Lightnings were already capable of missions no other fighters could match. Yet even they returned from long sorties with fuel margins so thin that bad weather or minor detours meant losing aircraft. McDonald noticed, 2 days after Lindbergh's arrival, he called a meeting. The pilots gathered under bare bulbs in the group's makeshift recreation hall. The floor was packed dirt, furnishings were minimal. MacDonald introduced Lindbergh formally and asked him a direct question. How was he doing it? What followed would permanently change P-38 operations in the Pacific. Standing beneath the bare bulbs of the recreation hut, Lindbergh explained what no one in the room had ever been taught. Standard P-38 cruise procedures, he said, were designed for simplicity and safety, not efficiency. Pilots were trained to cruise at 2200 to 2400 RPM with the mixture set to auto-rich. The setting felt comfortable, engines sounded strong, power was plentiful, but it burned fuel at an unnecessary rate. Lindbergh laid out a different approach. Reduce engine speed to 1600 RPM. Shift the mixture from auto-rich to auto-lean. Increase manifold pressure slightly to compensate, holding approximately 30 inches of mercury. Maintain an indicated airspeed of roughly 185 miles per hour. The result, he explained, was a dramatic reduction in fuel consumption without a meaningful loss of cruise performance. Under these settings, fuel burn dropped to roughly 70 gallons per hour. Efficiency climbed to nearly 2.6 miles per gallon. Compared to the group's standard cruise profile, the savings were extraordinary. Lindbergh estimated that the Lightning's combat radius could be extended by nearly 400 miles. Missions approaching 9 hours were achievable. When he finished, the room was silent. The pilots were not impressed, they were alarmed. 7-hour missions were already exhausting. The P-38 cockpit was cramped. Pilots sat on parachutes with emergency rafts and survival gear beneath them. Heat, vibration, and fatigue made long flights punishing. 9 hours sounded inhuman. More troubling was Lindbergh's recommendation to run engines over square, a condition flight training had drilled them in as dangerous. Pilots were taught that manifold pressure should never exceed RPM by a significant margin. Over-square operation, they believed, caused detonation, overheating, and catastrophic engine failure. Now a civilian was proposing they do exactly what instructors had warned them never to attempt. Several pilots openly challenged him. One called the technique reckless. Another said it would destroy engines in weeks. Lindbergh listened without argument. He did not debate theory, he pointed to results. He had flown combat missions using these settings. His aircraft showed no abnormal temperatures. Oil pressure remained stable. Cylinder head temperatures, the true indicator of detonation, were often lower than during high RPM cruise. MacDonald understood the moment. Lindbergh was not asking for blind trust. He had already proven the technique in combat. The question was whether the group would test it themselves. They did. The first pilots tried the settings cautiously, flying short sorties close to base. Engines sounded different at low RPM, a deeper, unfamiliar rumble that made pilots uneasy. But gauges told the truth. Temperatures stayed normal, pressures remained within limits, nothing failed. Confidence grew. Pilots used the technique on longer missions. Fuel savings became impossible to ignore. Flights that previously required immediate return could now include extended patrols. Targets once considered barely reachable now allowed time over the objective. The Lightning's effective radius stretched from roughly 570 miles to more than 750, then 750 miles. Pilots reached distant targets, fought for 15 minutes, and still landed with an hour of fuel remaining. What had once been theoretical became routine. Skepticism evaporated. Lindbergh continued flying with the 475th, leading missions and teaching by example. When he led flights, his call sign was simple, Mr. Lindbergh. Rank meant nothing. Performance meant everything.
He explained why the technique worked. Power came from pressure, not RPM. High RPM burned fuel rapidly without proportionate gain. Lower RPM with moderate manifold pressure produced the same usable power with fewer combustion cycles. Lean mixture eliminated excess fuel used for cooling at high power settings. The engines did not detonate because the power setting was moderate, far below war emergency levels. Mechanical stress was actually reduced. His expertise came from decades of experience. The Atlantic crossing had taught him that limits were often misunderstood. Pan-American survey flights had given him thousands of hours to experiment. The P-38's twin-engine design made experimentation safer. If one engine failed, the other could bring the pilot home. The calculation proved correct. No engines failed because of Lindbergh's settings. By late July 1944, the technique was spreading beyond the 475th. Other 5th Air Force P-38 units began adopting it. Lindbergh briefed additional squadrons, answering technical questions and addressing maintenance concerns. Adoption was gradual but relentless. Then came July 28th. That morning, Lindbergh flew with the 433rd Squadron on a bomber escort over LPD Bay. Enemy aircraft appeared, 2 Mitsubishi K-51 Sonyas returning from reconnaissance. One was flown by Captain Saburo Shimada, commander of the 73rd Independent Flying Chutai. The American fighters attacked. What followed was a prolonged engagement. Shimada maneuvered skillfully, turning inside faster P-38s. One Sonya was hit and destroyed. Shimada continued fighting for 30 minutes, evading repeated attacks. Then he turned directly toward Lindbergh. The two aircraft closed head-on at nearly 500 miles per hour. Lindbergh centered the Sonya's engine and fired. For 6 seconds, the P-38's nose guns poured fire forward. The Sonya's propeller slowed, smoke erupted. At the last moment, Lindbergh pulled up, passing just overhead. The Japanese aircraft dove and struck the ocean at high speed. Unofficially, the pilots agreed. Lindbergh had delivered the fatal burst. The kill was never entered into official records. He was still a civilian. Paperwork would end his presence. Silence preserved his mission. 3 days later, Lindbergh nearly died himself.
On August 1, 1944, Lindbergh's luck nearly ran out. The mission was a fighter sweep toward the Palau Islands, a region increasingly contested as American forces pressed westward. During the engagement, Lindbergh found himself in a turning fight with the Japanese Zero, an aircraft lighter and more agile than the P-38. The Zero pilot gained position and came dangerously close to delivering a fatal burst. Lindbergh, focused on maintaining control, did not immediately see the threat developing behind him. Charles McDonald did. Over the radio came the urgent call, "Break right, break right." McDonald rolled in and engaged the Zero himself, forcing it off Lindbergh's tail. The intervention likely saved Lindbergh's life. The incident underscored a reality 5th Air Force leadership could no longer ignore. Lindbergh had proven his methods. He had flown roughly 50 combat missions in the Pacific, including approximately 25 in P-38s with the 475th. He had participated in aerial combat. He had demonstrated the effectiveness of his techniques beyond dispute. Continuing to expose a civilian consultant to lethal combat risk was no longer justifiable. The decision was made quietly. Lindbergh would return to the United States. On August 12, 1944, he departed Hollandia. Pilots of the 475th gathered to see him off. Their respect was genuine and hard-earned. Lindbergh had not arrived as a celebrity demanding attention.
He had flown their missions, endured their conditions, and proven his ideas in the same sky where mistakes killed without mercy. He left as one of them. The techniques he introduced did not leave with him. By early autumn 1944, Lindbergh's cruise control methods were spreading throughout P-38 units across the Pacific. Specific RPM and manifold pressure settings varied by aircraft model and operating conditions, but the principle remained constant. Lower RPM, moderate manifold pressure, lean mixture. The results were unmistakable. Targets once considered unreachable became routine. Japanese airfields previously beyond escort range now faced fighter cover. Bomber missions once flown without protection gained escorts that could remain over the target area and still return safely. Extended fighter range penetrated deeper into enemy-held territory. The strategic implications were immediate. In the second half of 1944, extended fighter range supported General MacArthur's rapid advance toward the Philippines. Airfields that once required costly amphibious assaults now could be bypassed. Operations that would have taken months accelerated into weeks. Time, more than distance, became the decisive advantage. Lives were saved. Pilots returned with reserves instead of empty tanks. Weather diversions no longer guaranteed losses. Damaged aircraft had a margin to make it home. The extended range reduced non-combat attrition as effectively as it improved combat effectiveness. There was resistance. Some commanders worried about engine wear. Some maintenance officers remained skeptical. But data silenced doubts. Engine failure rates did not increase. Fuel logs confirmed dramatic savings. Mission reports documented success that had previously been impossible. By late 1944, Lindbergh's methods were formally incorporated into P-38 operating procedures. Updated cruise charts reflected his findings. Training materials changed. What began as an unofficial experiment became doctrine. Lindbergh's Pacific service revealed more than a technical breakthrough. It showed how rigid institutions adapt under pressure. His pre-war politics had made him unacceptable in uniform. Presidential opposition kept him out of the chain of command. Yet the Army Air Forces needed exactly what he knew. The solution: unofficial civilian status, informal authorization, practical testing, was irregular but effective. Pilots judged Lindbergh not by politics but by performance. Major Richard Bong, America's top ace, called him as hot a pilot as any of us. Coming from Bong, the assessment carried weight no official endorsement could match. Lindbergh returned home without ceremony. He continued advising on aircraft performance, evaluating captured enemy aircraft, and assisting manufacturers. But his most significant contribution had already been made. He had taken an aircraft believed to be operating at its limits and revealed untapped capability hidden within accepted procedures. He had shown that understanding could be as decisive as firepower. And he had done it by flying the missions himself.
The full impact of Lindbergh's work became unmistakable during the liberation of the Philippines. When American forces landed on Leyte in October 1944, fighter coverage was no longer constrained by distance in the way it had been only months earlier. P-38 units flying from bases in New Guinea and Morotai were now able to escort bombers and patrol combat zones over ranges that previously would have left them dry over open water. The difference between arriving with empty tanks and arriving with an hour of fuel meant the difference between symbolic presence and real air superiority. The range extension reshaped operational planning. Air commanders could schedule strikes without waiting for closer forward airfields. Islands that once would have required costly amphibious landings to support fighter operations were bypassed entirely. Japanese positions found themselves isolated not by naval blockade alone, but by fighters that could appear far beyond expected limits, remain overhead, and still return home safely. These changes were measurable. Before Lindbergh's techniques, the P-38's practical combat radius hovered near 570 miles with reserve fuel. After adoption, routine missions stretched to 750 miles. With drop tanks and favorable conditions, 9-hour sorties covering nearly 1,000 miles became achievable. What had once been exceptional became ordinary. The effect on pilot survival was equally important. Fuel exhaustion had been a silent killer in the Pacific. Vast distances left little margin for error. Lindbergh's cruise settings provided that margin. Pilots forced to divert because of weather or combat damage now had options. Aircraft that would have been lost at sea made it back to base. Over thousands of sorties, the cumulative reduction in losses was substantial. Despite mounting evidence, resistance lingered in some quarters. Certain commanders worried that long-term engine wear might compromise readiness. Others were reluctant to abandon procedures drilled into pilots since training. But maintenance data told the story. Engines flown under Lindbergh's settings showed no abnormal failure rates. In many cases, lower RPM operation reduced mechanical stress and heat. By December 1944, Lindbergh's methods were officially incorporated into Army Air Force's manuals for the P-38. Cruise control charts were rewritten, training syllabi updated. The Lightning's true capabilities were finally reflected in doctrine. What made the achievement remarkable was not simply the technical gain, but how it was achieved. Lindbergh did not impose authority, he persuaded through evidence. He flew the missions, he accepted the same risks. Pilots trusted him because they saw results firsthand. The broader implications reached beyond one aircraft. Lindbergh demonstrated the value of civilian expertise in modern warfare. Industrial-age conflict depended not only on bravery and command, but on technical understanding. His success encouraged commanders to listen more closely to civilian engineers, test pilots, and manufacturer representatives embedded in combat theaters. The P-38 itself proved uniquely suited to the transformation. Its twin engines provided redundancy that allowed experimentation. Its fuel system supported precise management. Its stability made it ideal for long-duration cruise. Though the P-51 Mustang would eventually assume many escort roles, the Lightning remained indispensable in the Pacific, where range, firepower, and safety over water mattered most. The numbers confirmed its dominance. The 475th Fighter Group became the highest-scoring P-38 unit of the war, with 551 aerial victories. Major Thomas McGuire, America's second highest-scoring ace, achieved his successes in Lightnings flown using the extended range techniques Lindbergh helped refine. Yet Lindbergh himself received no medals, no official citations, no formal recognition. His reward came from the pilots who flew farther, fought longer, and came home alive because of what he taught them. His influence endured. Decades later, veterans of the 475th could still recite his recommended settings from memory. They remembered the civilian who proved that doctrine was not destiny, and that limits were often habits mistaken for laws. The war moved on. New aircraft arrived. New fronts opened. But the principle Lindbergh demonstrated remained timeless. In warfare, understanding the machine can be as decisive as courage in the cockpit. And sometimes, the most powerful weapon is knowledge, applied precisely and proven under fire. When Charles Lindbergh departed Hollandia on August 12, 1944, there was no ceremony, no speeches, no formal farewell. The pilots of the 475th Fighter Group gathered quietly as his transport aircraft lifted off the strip and disappeared into the Pacific haze. He left behind no official orders, no signed doctrine, no public acknowledgement of what he had done. Yet within weeks, nearly every P-38 unit in the Pacific was flying farther, fighting longer, and returning safer because of what he had taught. Lindbergh returned to the United States a changed man. His wartime service would never be publicly celebrated in the way his 1927 flight had been. Politics still shadowed his reputation. President Roosevelt never forgave him. Lindbergh would not wear a uniform again. But inside the Army Air Forces, among pilots and commanders who understood what had happened in the Pacific, his contribution was undeniable. By early 1945, the extended range of American fighters had become a strategic given. Air power no longer advanced only as fast as airfields could be captured. Fighters reached across distances that once protected Japanese strongholds. The island-hopping campaign accelerated. Targets that once demanded amphibious assault were bypassed. Japanese garrisons were isolated, starved, and rendered irrelevant. The P-38 Lightning, once constrained by conservative doctrine, now operated near the edge of its true capability. Its twin engines carried pilots across empty ocean and back again. Its extended reach helped clear the skies over Leyte, Luzon, and the approaches to Japan itself. What had begun as an informal lesson in a palm-thatched briefing hut became embedded in the machinery of American air doctrine. Lindbergh's work also carried a deeper lesson for modern warfare. Technology alone does not guarantee advantage. Neither does experience. Progress often comes from individuals willing to challenge assumptions with evidence, to test ideas in real conditions, and to accept personal risk to prove a better way forward. He had done exactly that. At 42 years old, Lindbergh flew combat missions against younger men who had grown up idolizing his earlier achievements. He never invoked his fame. He never demanded deference. He earned credibility the only way combat allows, by flying the same missions, facing the same danger, and producing results no one could argue with. The men of the 475th Fighter Group remembered him not as a celebrity, but as a pilot who understood machines at a fundamental level. A man who trusted mathematics over habit, who believed limits were often artifacts of fear rather than physics. After the war, many of those pilots would return to civilian life carrying lessons learned not just in combat, but in thinking. That progress requires questioning. That improvement comes from understanding systems deeply. That doctrine must evolve or fail. Charles Lindbergh died in 1974, buried quietly in Hawaii, beneath a simple stone bearing a line from the Book of Psalms. No mention of P-38s, no mention of combat, no mention of the Pacific. But the men who flew there knew. They knew that in the summer of 1944, a civilian walked into a fighter group's recreation hall and showed them how to fly beyond what they believed possible. They knew that the difference between running out of fuel and coming home sometimes came down to knowledge shared freely and proven under fire. And they knew that for 6 critical weeks in the Pacific War, one man changed how America fought, not by force of rank or politics, but by understanding the machine, trusting the numbers, and having the courage to prove that the impossible was simply misunderstood. That is Lindbergh's Pacific legacy.